Okay, we're back, ready to start example B. April and Michelle work at Wendy's. Together they worked 68 hours this week. If April worked 10 more hours than Michelle, how many hours did each girl work? So our first step is to identify the unknown. So I'm going to underline that in red. That is, how many hours did each girl work? So that is what we're looking for. Okay, we've got April and we have Michelle. We're going to assign variables to the number of hours that each of them worked. So I'm going to say, let A equal the number of hours April worked, and let M equal the number of hours Michelle worked. Okay, so we know we're looking for the number of hours each girl worked. We have identified our variables as A and M. Now we go back to our problem and try to find two sentences or phrases that will help us write two different equations. So I'm going to go in here and start reading again. April and Michelle both work at Wendy's. Okay, not much information there. Together, they worked 68 hours this week. That tells us some good stuff. Together, meaning adding their hours together, they worked 68 hours. So I'm going to write my equation 1 using that information. So April's hours plus Michelle's hours equals 68. So A plus M equals 68. Then it says, if April worked 10 hours more than Michelle, how many hours did each girl work? Well, we've already taken care of the last part of the sentence. That's the unknown. But the first part says April worked 10 hours more than Michelle. Okay, so if April worked 10 hours more than Michelle, this is going to be my second equation. That means that April's hours equal Michelle's hours plus 10. There's our system. Now this system, when I solve it, I think I'm going to use substitution because look at right here, this A is already by itself. So I can take this M plus 10 and stick it right in for that A. Let's do it. So that would be M plus 10 plus M equals 68. Now there's nothing to multiply inside these parentheses. There's nothing to distribute. So I can kind of just ignore them and combine like terms. I've got M and another M. So that's 2M. And then I have plus 10 equals 68. I will subtract 10, which will give me 2M equals 58. And divide by 2. And that gives me M equals 29. Now I know what M equals. I can plug that into my A equals equation, and that would be A equals 29 plus 10, so A equals 39. So our answer, in a complete sentence like it asks us to do, we would say for A equals 39, that means April worked 39 hours. And the M equals 29 means Michelle worked 29 hours. Okay, wonderful. Let's move on to C. Daryl's school is selling tickets to the play. On the first day of ticket sales, the school sold 3 adult tickets and 5 child tickets for a total of $27. On the second day, the school took in $51 after selling 9 adult tickets and 5 child tickets. How much does each type of ticket cost? All right, that last sentence is the golden ticket, haha. That gives us our unknown. we want to know how much does each ticket cost. So we have adult tickets and child tickets. So I'm going to use the variable A for the cost of adult ticket and the variable C for the cost of a child ticket. All right. Now we go back to our problem and we read and we try to find information that we could write two equations about. First sentence just tells us that we are selling tickets. The second sentence says, on the first day of ticket sales, the school sold 3 adult tickets and 5 child tickets for a total of $27. I think that is important. 3 adult tickets and 5 child tickets for $27. Now keep in mind that we know the number of tickets is given to us while our cost is our variable. And think about this. Let's say we knew that the cost of a ticket was $6 and we sold 4 tickets. Let's pretend the cost was $6 and we sold 4 tickets. Well, to find how much money we make, we would just take $6 times 4, right? We're like, oh, that's 24 bucks. Great. Well, now I don't know the cost. The cost is my variable. So this is going to help us write our equation. We are just going to take, we have 3 adult tickets. So we're going to take 3 times A, 3 times how much an adult ticket costs, plus 5 child tickets times C, how much a child ticket costs, and we're going to get $27. That's our first equation from my blue underline. Okay, the next sentence says, on the second day, the school took in $51 after selling 9 adult and 5 child tickets. So this is the same idea. The order of the information is just reversed. We sold 9 adult, so 9A, plus 5 child, 5C, and we made $51. All right, we have a system. Now this system is pretty nice because it's in standard form, both of them. My variables are stacked on top of one another. And something that's even better is that my C's both have a coefficient of 5. And remember, this looks like a perfect case for elimination. So I'm going to, because both the C's coefficient are 5 and I want them to be opposite, I'm going to multiply by -1 on one of them. I'll just do the top one and write the new equation down here. -3A minus 5C equals -27. So now I can eliminate C because I made the coefficients opposite, so by adding these two equations. 9A minus 3A is 6A. My 5C and -5C cancel. 51 minus 27, again, don't be afraid to use your calculator if you need. But you should get, you should get 24. And then you should divide by 6 and you get A equals 4. Now I need to plug that into one of my equations. I'm going to plug that into the first one that I kind of crossed out here. 3 times A, 4, plus 5C equals 27. 12 plus 5C equals 27. Subtract 12, 5C equals 15, divide by 5, C equals 3. So remember that A represents the cost of an adult ticket and C represents the cost of a child ticket. So our final answer in a sentence would be an adult ticket costs $4 and a child ticket costs $3.